Hello everyone, welcome to my channel. In our previous video, we successfully solved exercise question number 33. I hope you practiced all the questions we have covered so far and understand the concept behind each solution. In today's video, we will continue with the remaining questions of Unit 1 and solve them one by one with detailed explanation. So, try to solve each questions on your own before checking the solution. So, without wasting time, let's get started with today's questions. Question number 34 says a big wheel at the theme park has a diameter of 14 meter and people on the ride complete one revolution in 44 seconds. Calculate A. The distance a rider moves in 3 minutes. B. The distance of the rider from the starting position. In this question, they mention about a big wheel. It is like circular in shape. Okay. In this question, they say big wheel means it is kind of a circle. Now, its diameter is 14 meter. So the diameter is it is center of the big wheel and it is a diameter D, you can say. So D is equals to 14 meter. Now, people ride in complete one revolution in 24 seconds. Means if take this point as a person and it moves around the circle and it back this same position in 24 seconds. Okay, it is called time period. Okay, so time period of the big wheel is 24 seconds, and we have to find the distance of the rider moves in 3 minutes. So in one rotation, it takes 24 seconds. Okay. Here I mentioned the diameter is the time for one complete rotation is 24 seconds. So we have to find the distance traveled by the rider in 3 minutes before in 24 seconds it completes one rotation. So it means that one complete rotation, the distance, not displacement. Okay. If displacement, it will be zero because it comes to same position now. But in distance, it may it equal to circumference means 2 pi r. R is the radius of that wheel. Here they give us diameter. So we have to modify the equation like this. Pi into d. D means diameter. Diameter is given by twice into radius. So here I take pi into d. Now the circumference is pi into d. Pi into d. D is 14 meter. So I get the answer 43.98 meter. Means the person traveled in the one rotation is this meter. Now they give us 3 minutes. So first convert into the SI base unit. So you have to multiply by just 60 seconds. So it will be 180 second. Okay, second is the SI base unit of time. Now, so find the distance. So first we have to find how many revolutions takes in 3 minutes. So for that, the formula is total time upon time for the one revolution. So it means 180 is a total time and time for one revolution is 24 seconds. They mention here. Now the answer is the 7.5 revolutions it takes in 3 minutes. But we have to find the distance traveled by the rider. That is number of revolution. This means 7.5 into circumference pi into d. So we have to just multiply it and we got the answer 330 meter. So the answer is A. is 330 meter. Now in B, the distance of rider from the starting position. So in B, they exactly mention from the starting position. Now the distance rider now in 3 minutes. So we also already found how many revolution takes in 3 minutes. It is 7.5. 7.5 means this is a big wheel and this is the center. One complete revolution, second, third. After seventh complete revolution, it is here. And but we have 7.5 means half. We have to add half, and it will be here. Now, this is the starting point, and this is the ending point. So you have to find this distance. Okay. So what is it? This is diameter. Okay. It will be like this also. It is it is also diameter here. So I mentioned here the seven full revolution bring the rider right back to the exact starting point. The remaining half revolution places the rider on the diametrically opposite side of the wheel. Because the rider directly opposite their starting position, the circular path, the straight line distance separated from the start is equal to the diameter of the wheel. So the straight line distance is diameter is 14 meter. So our answer is 14 meter. I hope you understand these questions. Okay. Now question number 35. In question number 35 says state whether the following quantities are scalars and vectors. We already understood about the what is a scalar and which quantities are vectors. So they give a time of departure of train. It means it gives time, okay? Second is acceleration due to the free fall. We have to interest in acceleration means acceleration. The density of liquid, any kind of liquid. So it means density. So from this, we have to tell them which one is scalar and which one is vectors quantity. So the 31st solution is here scalar. Now the time is absolute and every direction. So it is a scalar quantity. Now acceleration. Acceleration is given by dv upon dt means delta v upon delta t. Here v is the not the speed. Here v is the velocity. So being a velocity is a vector quantity. Acceleration is also a vector quantity. So it is a vector quantity. Now the density. Density is given by mass per volume. Here mass is also scalar quantity. Volume is also scalar quantity. That means density is also scalar quantity. This is all about question number 35. Now we will move on question number 36. State whether the following quantities are scalars and vectors. The same question as 35. Now the here this is the temperature, okay? The time, frequency of vibration, frequency, and the flow of water in the pipe means some kind of flow rate. Now the temperature is scalar quantity. We mainly deal with temperature in thermodynamics. The frequency in when we talk about waves, vibration, then we will define the frequency uh, unit, which is a hertz, or you can say second inverse. We will see in a waves and a optics part, but this time I will only tell you about the SI unit so that you can easily identify the whether it is scalar or vector. So frequency as a unit of second inverse or hertz, name after the scientist. Second inverse, second is also a scalar, so it is a scalar quantity. Now, the flow rate, which is also part of some kind of fluid mechanics when you talk about it. So it is flow rate means we will consider as a velocity of the fluid. So we know the velocity is vector, so it is a vector quantity. It's about 36 solution. Now, question number 37. Speed and velocity have the same units. We all know the SI units of speed and velocity is meter per second. But explain why speed is scalar quantity whereas velocity is a vector quantity. They say the speed and velocity has the same units, okay? So why speed is vector scalar and velocity is vector quantity? For that, we have to go into the definition of speed and velocity. So the speed we will see in the kinematics part, speed is defined by the distance traveled by an object and it's taken a time. On other hand, the velocity is given as the displacement of an object upon taken time. Here you see denominator is same, okay? So we have to neglect it. But the speed is directly proportional to the distance. Velocity is also uh, proportional to displacement. Here, distance and displacement. Some people treat these two quantities same, but it is not. Sometimes it will same, but not every time. So distance is scalar quantity, and displacement is vector quantity. Let me give one example. Here is a point, and here is a B point. Now, one person take this route, another person takes this route, and the third person is take straight. Okay, first, second, and third. Now, in the case of distance, it will take original path. Okay, May, uh, if first in case first, it is like this distance plus this distance plus this distance. Okay, we have to just add it. In the second case, distance is this plus this and this. In the third case, distance is this. But in case of displacement, it only depends on the initial and final point. Okay, means displacement it takes straight away. So this is the point A and B. It is called distance as well as displacement. Let's take some other example. If there is a circular track, okay. Now one person is running diametrically and it takes 7 rounds and the radius of this track will be 1 meter. Okay. Now in that case, it takes distance. It cover distance around 2 pi r into 7. Okay. And it will give you some non-zero value. Okay. But Whenever you calculate displacement of the same track, same radius, same person, and same 7 rounds, but whenever he or she completes its round 7, it it is the starting point. So the displacement of his it is zero. So this is the basically fundamental difference between distance and displacement. So velocity is given by this displacement and the speed is given by this distance. So from that we can say speed is a scalar and velocity is a vector quantity. Now, in question number 38, a student states that a bag of sugar has weight of 10 Newton. Weight is 10 Newton. That this weight is a vector quantity. Discuss whether the student is correct when starting that weight is a vector. In my first uh, video of Unit 1, I mentioned that the weight is vector quantity. On the other hand, mass is scalar quantity. So keep in mind, some students are confused whether the mass is vector or scalar or weight is scalar. So keep in mind, and the student is correct because he says the weight is a vector quantity. So weight is a gravitational force acting on the object. Because force is a vector quantity, okay, we talk about force in a dynamics part. At that time, we will discuss the force is vector quantity. The weight also has a both magnitude as well as the direction acting vertically downward the center of the earth or the source of gravity. So there is a mass on the earth. It always pulls by the earth and we call as gravity. So weight is vector, okay, vector quantity. So keep in mind. So this is all about question number 35 to 38, and it is very easy questions. Now we move further on question number 39. In question number 39 says a ship is traveling due north with a speed of 12 kilometer per hour relative to the water. There is current in the water flowing at the 4 kilometer per hour in an easterly direction related to the shore. Determine the velocity of the ship relative to the shore by scale drawing and the calculation. In this question, they talk about the ship is going north at this speed and the current of the water is flowing about 4 kilometer per hour in the easterly direction related to the shore. Now we have to find the velocity of the ship related to the shore by these two various methods. So the first method is scale drawing. I hope you have a scale or ruler. So I mentioned here the some diagram of the this is the boat speed, okay, or you can say ship speed, okay, and this is the current of water speed, okay. So you have to find the resultant vector we talked about earlier, like we have to add some vectors. We have to found the resultant one. So we have to use not normal method. We have to use tip to tail method. So first, I am talking about the scale drawing. How to do that? So in a scale drawing, choose a suitable scale. So if you have a scale and draw in your notebook, so take 1 centimeter of your ruler, it 2 kilometer per hour. So draw a first vector of the ship, and it has some speed of 12 kilometer per hour. Means Vs means 12 kilometer per hour. So you have to just draw the straight line of 6 centimeter, because here we take suitable scale. 1 centimeter means 2 kilometer per hour. So 6 centimeter means 12 kilometer per hour. Now it is a let me define first the direction: north, south, west, and east. So the ship is heading to north. So it is north. Now the current in the water flowing 4 kilometer per hour in the easterly direction. Now they say 4 kilometer per hour. So I here mentioned that how to draw a second vector from the tip of the first arrow, means from this point. Draw a horizontal line pointing directly east to the length of 2 centimeter. Now we have to draw a 2 centimeter line. Why? Because here they give us 4 kilometer per hour, means 2 centimeter into 2 means 4 kilometer per hour. Now in the third step, measure the resultant. Now draw a line from the of the first vector. Tail of the first vector is from starting from this, and tip of the second vector. Tail from the first vector and tip of second vector, like this. You can draw from the ruler so you can get exact value. Here I drew by hand, so it may not give accurate value. This is a resultant vector, okay? So you have to just find resultant vector. So if you measure its length with a ruler, it will be approximately 6.3 centimeter. Now it is a scale meter is 6.3 centimeter, but in the suitable scale, we chose 1 centimeter means 2 kilometer per hour. So we have to find the velocity of the ship relative to the shore. So we have to multiply by it by 2, and you got the answer about 12.6 kilometer per hour. So this is a method known as scale drawing. In that, first you have to choose some suitable scales depending on the question, and the second draw first vector, we draw the ship vector, then we draw current of the water vector from the tip of the first vector, and then we joined the tail of the first vector and the tip of the second vector, and we got the resultant vector. And we have to just measure by the ruler, and you got the some kind of centimeter, and just you have to multiply by what you considered before and use scale. But just like this. Now it is called the scale drawing, but you have to also find a direction. So far we discussed about the what is the value of r, but we do not consider direction. So we have to consider direction. So how we find the direction? So for direction, use protractor to measure the angle between the north vector and the resultant vector. So use that instrument and got result by 18 degree. Now this is all about scale drawing. Okay. Now the second method to get the answer is by the calculation. I from my earliest videos I mentioned the cosine rule, means resultant vector means first vector second vector square plus 2 f1 f2 into cos theta. Use this formula to determine or to find the resultant magnitude. So you know F1, F2, but to show the how to find the theta. So for that, you know the ship direction is north and the second vector is in the east direction. So take F1, second is F2. So the angle between these two vector is 90 degree. And you all know what is the cos 90 means 0. So negate this term and find the resultant by using this formula and put the values of F1 and F2. You got the 30 kilometer per hour. It is most similar like you got in by scale drawing method. Okay. In scale drawing method, you got 12.6 kilometer per hour, and by calculation, you got the answer in 30 kilometer per hour, which is kind of same. Okay. Now, in scale measuring method, you got direction as well. So how do we find direction in using the calculation method? So for that, again, I draw vector of sheep, or you can say F1. Okay, and another vector is F2 of stream of the water, and I just the resultant one is like this. Okay, this first vector, second vector, and resultant vector is about like this, and we have to just do make angle and theta with F2, or you can do theta as well here. Okay, so choose one. Here I choose this theta. If you want this make theta angle, so you can do as well. So for that, we have to what is the tan theta? Tan theta means opposite angle, means F1 upon adjacent upon F2. Put this value and you got the answer 0.333 and convert in theta means 18.4, but it is most likely 18, and we got the same answer. Okay, and we have to mention east of north means this direction. Okay, northeast you can say. Now this is all about uh, question number 39, and in that question we saw how we find scale drawing method and how we found the answer by the calculation, and by the two method we found the same result. Okay, so in exam, if they not mention about any kind of method, you can go for anyone. And if they mention, so as they said. Okay, now question number 40. In question number 40, explain how an arrow may be used to represent a vector quantity. Two forces are magnitude 450 to 40 Newton respectively. Determine the maximum magnitude of the resultant force, minimum magnitude of the resultant force, and C, the resultant force when the force act right angles to each other means they are like this, F1 and F2. Now we already saw how to deal with this kind of vectors in question number 39. Okay. So in A, they say a maximum magnitude of the resultant force. So how we got the maximum magnitude? If one vector is of this direction and another one is also in the same direction, then and only then we got the maximum magnitude. If one vector is like this and another is some tilted by the theta angle, so you have to just find this amount by using a sine or cosine law, but it is not a maximum. In this question, they mention about the maximum magnitude. So we have to consider as the both vector are in the same direction. So here I mentioned equations. It's in the same directions here. You have to just add both direction, not cos and sine component appear here. Okay, it means 690, the maximum resultant. Okay, now in question B, they say a minimum magnitude. So in order to get minimum magnitude, you have to just do some opposite sign. It will be cancel out and it gives minimum value. Okay, so first we see a maximum magnitude if both vectors sign the same direction. And if we want to get minimum magnitude, so we have to just one vector opposite sign. Okay, so keep in mind. So the for the minimum magnitude, take one direct vector in opposite direction. You can also understand from this equation as well. As I mentioned earlier, this question is for resultant vector magnitude. So 2f1, f2, cos theta. So it is a constant. This is also constant quantity. So it depend on only cos theta term. So in cos theta, remember the table of the cos theta. Cos 0 means 1. Cos 180 means 0. Or you can say, sorry, 90 means 0. Or 180 means minus 1. So cos theta is between plus 1 to minus 1. Okay, so if we have to take minimum magnitude, take the value of theta, they give value of minus 1. So we take the theta is 180 and it will give us a minus 1. So it is here they give a minus. Okay. If we want to get maximum magnitude, so take cos 0. Okay. Cos 0 means in the same, the angle between these two vectors is not, it's the same. Angle is same. If we want to minimum magnitude, take 180 degree. Okay. Now the minimum result is resultant F1 minus F2, it is 280 Newton. And the last, C says the resultant force when the force at right angles. So here take F1 and F2 here, which are right angles. Okay, means they are at 90 degree. Now same formula, cos theta means 90, cos 90 means it will be term will be 0, and you left with this term, and you got the 510 Newton. For this, you have to also get direction. So take tan theta means opposite. Opposite means F2 upon F1 adjacent for 850 and get theta is equal to tan inverse this term, and you got the answer about 28.1 degree. Now it is all about question number 40. Now we move on question number 41. Question number 41. A boat can be rowed at the speed of 7 km per hour in still water. A river flows at the constant speed 1.5 km per hour. Use a scale diagram of to determine the angle of the bank at which the boat must be rowed in the order that the boat travels directly across the river. Okay, this is a very important statement here. So we have to find or determine, you can say, angle to the bank at which the boat must be rowed in order to boat travels directly across the river. Means there is a shore here, there is another end, and there is a river is flowing this direction. Okay, so We have to find that angle. From that angle, we can move further. So we can the trajectory, or you can say a boat is going straight way. Okay, this is the point A, and this is the point B. So they say that the what which angle we go, that we reach exactly at the B point. So in order to find that, question number 41, the speed of boat in still water is 7 km per hour, and the river speed is 1.5 km per hour. So you have to find this theta prime. Means this is the you have to across the river, and if there is a no current in water, the boat is gone from this to this direction easily. But here the current is in this direction. So if boat is starting this point, it will go this way. Why? Because the river takes this direction. So it may take some angle theta. So we have to found this theta angle. So if you start with this theta angle, let me, if you start with this theta angle, you come across at B because the river pulls you in this direction. Okay. Now from that, how we found this angle? So this is the 90 degree. Okay. I make some. This is 90 degree, and the boat is going like this. This is the ideal situation, but due to some current over here, the bolt trajectory will be like this. So you have to find this theta prime. So take this theta. The theta by the geometry, it will be, this is also theta. Now they give us a speed of boat in still water. Still water. The, that means this one. If there's a still water, means no current in the water, the boat is will go like this. But here they mention some kind of current are there in the water, so the boat is pulled by this amount. So the value speed of the boat is still water is 7, means this value. And they also mention the speed of river means 1.5 kilometer per hour, means this, sorry, this is a 7 kilometer per hour, and this one is 1.5 kilometer per hour. And this is a boat speed because it will drain towards river flow. Now take sine theta, not theta prime. Sine theta means opposite angle upon hypotenuse. Hypotenuse means 7. So find the theta, which is 12.4 degree. Okay. From this, you can easily measure the theta prime, which is asked in questions. So once we get theta, which is a 12.4 degree, and by we know the uh, addition of these three theta plus theta prime plus 90 means 180. So from this, theta prime means 90 minus theta, 90 minus 12.4 degree. It is also degree. So which it is 7.6 degree, which is the asked in our question. The angle of the bank at which the boat must be rowed in order to boat or traverse directly across the river. Okay. Now in question number 42, two forces act at a point P as shown in figure. Draw a vector diagram to scale to determine the resultant force. Check your work by the calculation. They say first do by scale diagram, by use your scale, and then you have to check by the calculation. As we did in question number 39, it is the same kind of question. Okay, so you can do by the scale drawing. Here you take 1 centimeter means 10 Newton. Okay, so draw 8 centimeter line for 80 Newton, draw 5 centimeter line for 50 Newton. Here they does not mention any direction, specific direction. Okay, so you can do like this also, you can do like this, anywhere. Okay, so here they didn't mention about the direction, so you have to do any direction. Okay, so make sure the angle between these two is 40 degree. So if you take 8 centimeter here, and if you another take 5 centimeter here, so make sure it will be 40 centimeter in between angle. Okay, or you can do like this also. Okay, but the angle between them is should be 40 degree. So if you do like this, and it will be 40 meter degree. So the first you can do as well, tip to tail method. Okay, use this and measure the resultant vector, which is about 12.3 centimeter, or in your scale you get 12.3 into 10 means 123 Newton. Okay, now we have to check by the calculation. Here we have calculation f1 square, f2 square, 2 f1, f2 cos 40. Why 40? Because the angle between these two forces is 40. Okay, and it will give 123. Okay, do yourself at your home by scale drawing method. Now, question number 43. A swimmer who can swim in still water, speed is 4 km per hour, is swimming is in the river. Okay, the river flows at the speed of 3 km per hour. Calculate the speed of the swimmer relative to the river bank when she swims. Okay, first one is downstream and second one is upstream. So if there is a river here, a person who swims opposite to the river stream, it's called upstream. And if the river flow is like this direction and the person is also swim in the same direction, it's called downstream. Okay, I hope you clear the foundation of upstream and downstream. So upstream, the river direction is like this. Okay, you can say river speed, and the swimmer speed is like this. Okay, they are both opposite. In our previous questions, here I mentioned opposite direction. They are the vectors. They are the vectors reverse vector quantity, velocity, and the speed. So if we have to find the you can say resultant, it will be river minus or speed of the swimmer, or you can, let's see, swimmer speed is still water is 4 km per hour. River current speed is 3 km per hour. For the downstream means both are in the same direction. Okay, the same direction, speed must be adds together. So R is equal to 3 plus 4 means 7 kilometer per hour relative to the bank. Okay, now in B, upstream means river is coming from this side and the swimmer is against to it. Now, if they are both in opposite direction means the angle between them is 180 degree. 180 degree means f1 square plus f2 square minus 2 f1 f2 means minimum speed, minimum. So speed is subtracted means 4 minus 3 means 1 kilometer per hour. So it is all about question number 43, which is very simple question. Now, question number 44, draw a scale, a vector triangle, determine the resultant of the two forces which are shown here. Check your answer by calculating the resultant. So again, by the scale drawing, and then we have to check by the calculation. I hope you understand the what is scale drawing. So I'm not getting into that, but here I talk about some in brief. For the scale drawing, take 1 centimeter to 1 Newton. Means here they take 6 Newton here, 9 Newton here. Take 1 centimeter, 1 Newton, and they give some specific direction or not. No, you have to just draw 9 centimeter by a scale and take another vector from the tip of the first vector and take 6 centimeter because we take 1 centimeter means 1 Newton, and then you have to just tail to the of the first vector and just add tip of the second vector and find the resultant by the ruler. Now, okay, now I write here resultant is f1 square, f2 square, and cos theta. Here, cos theta means the angle between these two vectors. One is going this direction, north, you can say, or another is going east direction. So the angle between this is 90 degree. So it will be gone. So we got 11 Newton means by you do scale drawing, you got the 11 centimeter. Okay. Now from the direction, you can do also measure by the protector. Okay. And by the calculation, we got the result like 34 degree. So do at your home by the scale drawing and compare with this calculated answer. It is all about question number 43 and 44. Now we go on question number 45. Question number 45. A cylinder is launched by an aircraft with a cable as shown in figure 1.33. At the one particular moment, the tension in the cable is 620 Newton. The cable makes an angle of 25 degree with horizontal. Don't bother yourself. They given us the figure, okay. So now to calculate the force pulling the cylinder horizontally. So you have to find horizontal component of that vector. In B, the vertical force exerted by the cable on the nose of the cylinder. So also you have to find the vertical component as well. So I have to just draw like this. This is the FV and this is FH. And they give us like this and angle between horizontal component 25 degree and this is the F and which is a 620 Newton. Now, if you want to find FH, so take cos theta. Cos theta means adjacent upon hypotenuse. Then make a subject FH and take F this side and you got the result FH means 561.9 Newton. In the case of, we have to find this angle. So there are two methods actually. Uh, you know, this is FH and this is FP. If they give us a 25-degree here, but we know all the angle between these two is 90 degree. So you got the answer here like X. Okay, you can use two formula, cos theta, cos theta, cos X means FV upon F, or also you can use sine 25 degree FV upon F. So both the formula are true. By these two formula, you can get the same result. Okay, because sine and cos are a sinusoidal wave function and which are differ by 90 degree. Okay, so both formula are correct. So I go through this formula sine theta FV upon 620 and FV got 262 Newton. This is all about question number 45. Now we go on question number 46. This both question are very easy. Now question number 46 says an aircraft is traveling 35 degree east of north. Now 35 degree east of north, 35 degree. Okay, at a speed of 310 kilometer per hour means 310 kilometer per hour. Calculate the speed of the aircraft in northerly direction and easterly direction. Northerly means you can say vertical, horizontal component, and this is the vertical component because the angle is mentioned here. Okay, so if you want to find Vn, so do cos 35 degree, cos adjacent value Vn upon hypotenuse means we already given which is 310. Got the answer of V. If you want to find Vn, Ve, sorry. So take sine 35 and the formula is like this. Sine 35 means this value is this value. Okay, these are the same. Means opposite angle upon hypotenuse. From this, you can easily find VE. Here I mentioned. Now, question number 47, which is similar to the 46. Now, the cyclist is traveling down the hill at a speed of 9.2 km per second. Some cyclist is going downward, like this is the hill, and this is going like this. The hillside makes an angle of 6.3 degree with the horizontal. Calculate the cyclist vertical speed and horizontal speed. Okay, for that, this is the mountain. Okay, and the cyclist going like this way, and the questions tell us about the six. It makes a 6.3 angle with the horizontal. So we have horizontal here, and it makes angle which is a 6.3 degree, and the velocity is 9.2 meter per second. So if you want to find vertical speed, means take we have to find this. Okay, no, not this one. Found this one means take sine theta, or for the horizontal speed, take cos theta. Okay, cos theta means adjacent value upon hypotenuse value. Okay, so this is about vertical speed and the horizontal speed. And with that, we have successfully completed all the exercise questions of Unit 1. Before ending the video, let's quickly go through these final slides. They summarize the most IMP concepts, formulas, topics from this unit. that you should revise before the examination. These points will help you strengthen your preparation and identify the areas that deserve extra attention. So, in SI units and homogeneity, we discussed the base units. There are seven base units. Five are in AS level, and two remaining two are in A level. And then we talk about Terra to Pico. There are many prefixes you have to remember and use while you solve the problem. One is a golden rule. LHS base units is must equal to RHS base units. This is the ultimate test for any physical equation. If in physics, in any area, they give some kind of equation, so to testify the equation, take LHS units and RHS units. If they are same, then the equation is right, valid, you can say. If they are not, the equation is may wrong. Okay. Now we also talked about errors and uncertainties. We give some detailed overview of systematic error and random error and how they cause and how we rectify them. And then we saw some how we combine uncertainties. If there is a formula like x plus y, z, if there is error in y and z, then we have to add in the x also. Now, if there is a multiplication, it will be like this or division also. And if your formula contains some power and the uncertainty will be like this. Now we also saw some basic difference between scalars and vectors. In scalars, they need not about direction and vectors. We have to mention about the direction. And also we saw some how to resolve vectors into components and show some method how we add some vectors unlike scalars is like tip to tail method. We, we did some problems on it. So this is all about unit 1. These are the main four topics of the unit 1. So what are the significance of this unit 1? Okay. So first one is the kinematics and dynamics. We will see the units of kinematics and dynamics. In that, we deal with some kind of vector quantities and scalars. As vectors, we have to just add by the tip to tail method. And we will use triangles, resolving of vectors, forces, momentum, and we discuss in 2D motions. When you come across some new formula, take the test of homogeneity, okay, which we will study in unit 1, and every time uh, write SI base units as well. And the last one, when you do some experiment or you perform a practical in exams, so you know the how we uh, calculate the uncertainties, okay, and random error and systematic error. So I hope you keep in mind and whenever whenever you use in that experiment. And with that, we have successfully completed Unit 1, including all the exercise questions and important concepts from this chapter. From the next video onwards, we will begin Unit 2, Kinematics, one of the most important and interesting units in physics. In this unit, we will learn about concepts such as a distance, displacement, speed, velocity, acceleration, equation of motion, some graphs, and the projectile motion, all explained in a simple way with examples. So stay connected with the channel and don't miss the first lecture of Unit 2, Kinematics. Thank you for watching. Keep learning, keep practicing, subscribe for more physics lectures.